Hello, everyone. You are here because you needed a little bit of support for number 6. Just forgive my voice. I kind of lost it today at school. I'm trying my best not to sound like a frog. So it's just gonna happen though. What you're looking at right now is just my markings on the number 6 problem. So just make sure that when you watch this video, you can go through and pause at any time. I tried to do all of it on the video, but my voice sounds too bad, and so I'm just gonna try to keep it simple. So for the first one, number 6, or for the first part in number 6, you just want to highlight all the important pieces, and I did that in the orange. And then I just went ahead and entered all of the native English speaker values into my L1 and all of the non-native speaker values into my L2. So what we're going to do is give you a second. You're going to pause the video if you need to, and you're going to enter those in yourself. And then when you come back, we will start with letter A. All right, so you can see my answer already. It's an experiment because she randomly sorted. So experiments are when you impose a treatment. And so she told people which group to go to and gave them something specific to do. So an observational study is if you're just observing. All right. So I noticed that I say I'll write a lot while I'm making these videos, but I'm still going to keep doing it, I'm sure. So let's get going on letter B. When you see the phrase, do these data provide convincing evidence? I want to be orange. Convincing evidence. And then more likely when the language is not English. Support your conclusion with an appropriate statistical test. So that's why I wrote 2 sample t-tests at the top. So I'm just going to kind of uncover some of the stuff I've already done, and you can follow along and pause when you need to, and then unpause when you're ready to keep going. So here is my P in pass. 2 sample t-tests for mu1 minus mu2. I decided not to use special letters because native English speaker and non-native English speaker were about all the same letters. It'd be more confusing, I thought. So what I do instead is you just make sure that you define it right here. You can't see my mouse. There we go. To the right. So I let mu1 be the true mean number of errors incorrectly identified in writing when the reader thinks the author's native language is English. I chose to do that because English was what was in my L1, and I wanted to make it match. So then I wanted the ones to be the same so I didn't get confused. And then I'm going to let my mu2 be the true mean number of errors incorrectly identified in writing when the reader thinks the author's native language is not English. I want to write the right thing here, so I'm going to fix that. Okay, so once we've done that, we have to just go to our HO and HA. And so the reason that our HO is always in equals, and then what I did for my HA was I chose a less than sign because the problem thinks we want to decide if readers are more likely to incorrectly for the non-native speakers. If non-native are my mu2, then the mu2 should be higher than the mu1. And so I use a less than sign when the mu1 comes first. Hopefully that makes sense. If not, then you can pause and ask a neighbor. All right, moving on. We have the assumptions and conditions. So what you'll see on mine is that for the random, I wrote randomly sorts into 2 groups because that is what we do. For random, we just quote where we see it. Now for normal, that one has 2 box plots because each of the samples is only size 20. Combined, there were 40 people, but there's only 20 in each group. And according to the rules that you learned today, there have to be 30 in each of the groups for the central limit theorem to apply. So what we do to get those 2 box plots is I'll show you right here on the calculator. So what you're going to do is have all the data entered into your L1. You're going to go to second y equals L1 and L2, I'm sorry. And what you want is you want your calculator screen when you hit second y equals to look like mine right here. We want plot 1 on and plot 2 on. We want plot 1 to have L1. And we want plot 2 to have L2. The way we make this happen is we hit second y equals, plot 1, L1, on, choose the box plot with the outliers, making sure it says L1. Then just scroll up and change plot 1 over to plot 2. Turn that one on as well. Go to type, choose the box plot with the outliers, and then hit second number 2 to make L2 come appear, Then hit zoom 9. And it will plot both box plots on the same axis for you to plot on top, one on top of the other, like you see on my screen. All right, and then the next thing we have is the independent condition, which we still need to talk a little bit more about when I get back on Wednesday. But independent condition, when there's not a random sample, when there's only random assignment for an experiment, is just the same thing as the random condition. So if there's two groups and they were randomly assigned to the groups, then those two groups don't affect each other, is what it means. So they're independent. All right, so our statistical work. Now, before we get there, I want to show you guys how to find all of your sample statistics. So what we need to be able to find are the X bar 1. We'll need X bar 1, X bar 2. I already have it filled in, but we need X bar 1, X bar 2, S1, and S2, and then N1 and N2. I filled them in to the right. If you know how to get those, great. You can skip ahead. If you don't know how to get those, then follow along here. Take your calculator, turn it on, and of course, go to Stat, hit Calc, and hit Enter. Change this to say L1, or make sure it says L1, then hit Calculate. And you get 0.85 for your mean and 1.089 for your standard deviation. And then your sample size is 20. Then I'm going to do it again. I'm going to hit Stat, Calc, Enter. I'm going to change this to second number 2, calculate, and that's where I get the 3.1 and the 2.553. Okay, then my sample size is 20 there. I get my test statistic. If you notice here, I plug all of this in, all in this area. Use the calculator, get an answer of negative 3.625. Draw your normal curve, put 0 in the middle, label down to negative 3.625, or as close as you can get, and then we're going to use TCDF. We've done this before. Second var 6, negative 9 to the 99, I'm going to put in negative 3.625. My DF is the conservative version, 19. I take my smallest sample size, which is 20, and subtract 1 from it, and then I hit paste. And then I got 9.0145 times 10 to the negative 4th. You can leave it like that, or you can move the decimal to the left 4 spots and write 0.0009. Either way, your p-value is less than the alpha. We reject the null. There is sufficient evidence to conclude that readers are more likely to correctly identify errors when they think the author's native language is not English. So that was a significance test that involved having 2 samples, and I just wanted to make sure you knew how to use the calculator to find the 2 box plots at the same time and the statistics for each sample mean X1, X bar 1, and X bar 2. All right, thanks for listening. I hope that it was helpful. Please email me if you have any questions, and I'm sorry that my voice was hard to listen to. Have a great weekend. Bye.